Okay, here we are in the last section, broken into three parts. We're looking at conic sections, and this conic sections that we're looking at are going to be parabolas, ellipses, and hyperbolas. So that's the order in which I'm going to break this into three separate little videos. So, in case you want to just look at this particular type of conic section, you don't have to look through the whole thing. All right, so like I said, parabolas, ellipses, hyperbolas. All right, now we're going to look at how their equations are going to be derived for a standard form. We refer to these as conic sections because we take a plane and intersect a cone, whether it's through one cone, like the ellipse and the parabola, or a hyperbola intersecting, if you will, two cones that are inverted. All right, so ways to approach conic sections, like I said, intersections of planes and curves. We're going to look at their algebraic. This is what we call the general form, where everything's all multiplied out and it's equal to zero. Not my favorite form, because just like with parabolas you learned in college algebra, the vertex form, it's much more suitable for graphing, and we have one of those. We have forms for that here that are more suitable for graphing, just like also in circles. And then we're going to look at, this is the definition that we're going to look at as a locus, or what we call a collection of points that satisfy a geometric property. All right, so we're going to get started here first with our parabola and its definition of a geometric property. A parabola is the set of all points, x, y, in a plane that are equidistant from a fixed line, that's called the directrix line, that's down here in blue, and a fixed point called the focus, not on the line. So here's your focus up here. The vertex is the midpoint between the focus and the directrix line. So that means these two segments are going to be equal to each other. So by the definition, it says from the focus to any point on your parabola has to be congruent or equal to that segment down to the directrix line. Boom, boom, all equal. All right. So to set up our definition, we're going to use their distance formula. So from P to F, we need to find the distance. So that's the square root of x squared, x minus 0 squared, and y minus p squared. And the distance P to the directrix line is going to be made up of these two distances right here. Y is your y coordinate, and the distance P, that's 0 to P, that these two are the same right in here. And here's our directrix line, y equals negative P. So the definition as an equation would be this, that these two have to be equal. So let's square both sides to get rid of our square root. Then we'll FOIL this out. We're going to get some cancellation here because we're going to get a lot of terms that are going to be closely related since we're squaring a binomial, one with a minus, one with a plus. So x squared plus y squared minus 2py plus p squared equals y squared plus 2py plus p squared. The y squareds are going to cancel. The p squareds are going to cancel, and we're going to add this 2py over to the other side, and now we've just solved for x squared. That's where the difference here is. When we talked about parabolas in college algebra, we solved for y equals, and we would have x squared, or a times the binomial x minus h quantity squared plus k. So it's all about having y by itself. Here we want the x variable being squared by itself. Now, so here these are not technically functions. So we can have y squared equal to 4px. Now those would be parabolas that open to the right or to the left that obviously don't pass the vertical line test like these two parabolas do, but it's a conic section. We can now have parabolas opening left and right, and we have an equation for them. So an equation of the parabola with a focus at 0p and the directrix line y equals negative p is x squared equals 4py. And if we switch everything around, an equation with the parabola with the focus at p comma 0 and the directrix line at x equals negative p is y squared equals 4px. So the following diagram is what I like right here. This really kind of explains everything. So just remember this, when you're used to having y equals x squared, if you have x squared by itself, you know you're opening up or down. And how do I know if I open up or down? You look for the p value, or what I'll call 4p. That's the coefficient in front of the y. That whatever scalar factor multiplied to y, if it's greater than 0, it opens up. If it's less than 0, it's opening down. That's where your negative is. So over here to the right, here's my y squared by itself. Now my p, or my 4p, is greater than 0, so that's going to give me a parabola that opens to the right with my directrix line being vertical now. And again, your focus always inside the parabola. Here's my y squared, but now if your 4p, or p is less than 0, we're opening to the left. Now, a nice little graphing assistance here, all right, is you have your vertical axis of symmetry. Real quick, if we talk about moving the vertex, then you have to add and subtract your h's and your k's from your x and from your y. Over here, now notice, got to be really careful with this form. All right, I see this mistake made lots of times. We're so used to having h before k, and there's your vertex, but over here it's y minus k squared, and on the right is x minus h. You've got to remember that the h goes first and the k goes second. So a nice little thought you should have in your mind is find the x, change the sign, find the y, change the sign. Find the x, change the sign, positive h, find the y, change the sign, positive k, always in that order. So you got to find the x to see who's going to be first for your vertex. But your graphing note, since this is a distance of p and this distance is p, these have to be the same. If you made a 90-degree angle at the focus, this distance is 2p because you would have to go straight down 1p, then another p, and that gives you a distance of 2p. So one way you can remember to graph this is when you find your vertex and you go to your focus, p units, make a left and right hand turn and double that p distance, and those will be points on your parabola that will be easy to find. So down here is my vertex. I go down p, I go to the right p and to the left p units, and there's 3 points I can graph on my parabola. Over here, all right, my p-value is coming from that value that's being multiplied to your y or your x's or your binomials here. So if I can find that p-value, 0 to the focus is p, left-hand turn, right-hand turn, double that distance to 2p, I have 3 points on my parabola I can graph. Negative p to the left to the focus, left-hand turn going down, right-hand turn going up, doubling that p-value to find 2 extra points on my parabola to graph. All right, so let's practice one here. Find the vertex, the focus, and the directrix of the parabola and sketch its graph. So what we need to do is we need to have y squared all by itself. Notice that there's only one variable in these equations that are squared. So I'm going to divide over the 2. Y squared is by itself. I notice nobody's being added or subtracted to my x or y, so that puts my vertex at the origin. To find my focus, this 5/2 is your 4p value, and since it's positive, it's going to be a parabola that opens to the right because we're starting with y squared. I'm going to set 4p equal to 5/2, solve for p, divide over the 4, and I get 5/8. So that means I'm going to the right 5/8, and so that would be 5/8, comma 0 for my focus. Now remember what I said. There's the p-value, 5/8. Double that, 10/8 or 5/4. Left-hand turn to 5/4 going up, right-hand turn 5/4 going down, and now I've got 3 points to draw my curve. All right, and my directrix line will be 5/8 going in the opposite direction of the vertex from the focus, and that's going to be a vertical line here because we're opening to the right, so that's x, not y, but x equals negative 5/8. This must be the equation of a line. You must have an equal sign here to whether it's x or y, depending on if it's vertical or horizontal. So I draw my parabola and we're done. Now, one thing for me, please don't go too far past these points. All right, I got a program making that point. we only have 3 points. So, once you get past here, no more than one square, just stop, put an arrow. And I don't mind if you put an arrow right at those points. That's good enough for me. All right, example 2. Now we're going to find the vertex, focus, and directrix line of a parabola and sketch it on the graph. But now notice we're adding and subtracting things to our x and the y, so that's going to move our vertex. So here, like I said, find the x, change the sign, -2. Find the y, change the sign, +3. There's your vertex. So we can go to -2, +3, plot that point. Now the x binomial is being squared, so that tells me this goes up and down, and 8 is positive. That's your 4p, your scalar factor. That's positive, so that tells me this is opening up. All right, so we'll take 4p, set it equal to 8. P is equal to 2. We need to count up 2 squares, so that's going to put us at -2. Add 2 to the 3, -2, 5. There's our focus. Now remember what we said. Vertex to focus is a distance of 2. Make a left-hand turn and double it. Make a right-hand turn, double it. And there's your points that you can plot on your parabola. Your directrix line will go down 2 points from the vertex in the opposite direction of the focus. This is now a horizontal line, so this is at y equals 1. Not 1, y equals 1. Not -2, 1, y equals 1. Draw your curve. And again, I have a program making this parabola. You can just stop at those points and we're good. That's it. Example 3, find the vertex, focus, and directrix, same type of thing, but now notice this equation is not in the form that we want. We want our x squared by itself. So either subtract over the 16 and move over the 2x squared, make it a positive, and subtract over the 12x. We want to isolate your x squared. Now you can leave it this way, or if you prefer to have the x squared on the left, that's fine too. Just move everything around, no big deal. But we need to complete the square of the left side. So I need to factor out the 2. I can't have anything multiplied to my x inside my binomial being squared. And so that blank on the inside has to be multiplied by 2. So notice I put that over on the right side. To complete the square, we're going to take half of your b term, so that's -3 squared. That will be 9. I never square this because now this x squared and this -3 squared, they make my binomial x minus 3 squared. Those are the two things that go into your binomial squared. And again, we don't want this 2 over here, so what we traditionally do is divide or multiply by 1/2 to the other side and keep this in parentheses. Don't divide it into everything. Remember, you have to have a binomial with your x in it, and you have to have a binomial with your y in it. So if you did make this 1/2 y plus 1, you would have to factor the 1/2 back out so you can have a binomial with 1y in the parentheses. So find your x, change your sign, +3. Find your y, change your sign, -2. There's my vertex. So 3, -2. There's my point. And since x, the binomial x is being squared, it's going to be opening up because 1/2, that's your 4p is positive. So set that equal to, oh my goodness, this is going to be a small p-value. Dividing over the 4 makes this 1/8. This can happen. So we're going to add 1/8 to -2 because it's opening up. Holy cow, -2, that's -16/8. That's -15/8. That's going to be right about there. And, let's see, 1/8, we'll double that. That's going to be a 1/4 to the left and a 1/4 to the right. Very close here, really tight. Directrix line, okay, we're going to have to subtract an 1/8 from the -2, so that's -17/8. And again, it's horizontal, so that's y equals. And now I got more of a parabola that's more vertical, stretching upward than it is. If you notice, some of the other ones are a little wider. All right, Example 4, find the equation of the conic section that contains a vertex at negative 2, 1. Okay, there's your h and your k, and a focus at negative 2, negative 1. So what I recommend, let's just plot the points. There's your vertex, negative 2, 1, and then there's your focus, negative 2, negative 1. So this parabola is opening down, so that tells me my 4p has to be negative, and my x has to be squared. So when I write my general format, x minus h squared, that's the binomial that's getting squared, and this 4p is going to have to be negative, so bring in the negative 2 and multiply it to this 4. Bring in your vertex, x minus a negative 2, y minus 1. There's all my substitutions, and there's my equation in what I would call standard form, because it gives me the vertex, and I can solve for p, and it tells me which way this opens up or down, in this case down. Now, if they want it in generalized form, then you got to FOIL all this out and set it equal to 0, and that would be our generalized form. That's the general form. Okay, example 5, let's try this one. Find the equation of a conic section that contains a directrix line of y equals 6 and a focus at the origin. So here's your origin, there's your focus. 6 squares up is your directrix. Where's my vertex? It has to be halfway in between, right there. So at 0, 3 is my vertex. And so here's my vertex, here's my focus. Again, it's opening down, so I need the same setup as before. And my p-value is going to be negative 3, so I've got the same setup. X minus h squared equals 4p, which is going to be 4 times negative 3, and y minus whatever your k value is. So if you put in the 0 for h, that's just going to give us x squared. And over here we're going to have y minus 3. And we put in our negative 3 for our p. We get x squared equals negative 12 times y minus 3. Now again, that's what I call standard form. Generalized form is to distribute the negative 12 and set this whole thing equal to 0. All right, that wraps up our parabola. So next video will be on our ellipse.